we can do more now than just 3 years ago, or just 2 years ago, or just 1 year ago. So there's definitely progress, but people are somehow that are not used to this or have this kind of ML background. I think they expect these systems to be 100% from the
Yeah.
get-go. And you're not going to get that. That's also one thing when I look at retrieval. I think also that's also a little bit of the frustration from people coming into now the retrieval space and search space, is that they're expecting more, that the system will be perfect from the get-go, and then they'll start looking for different methods. Oh, I tried this method, I read about it on Twitter, and I'm trying retrieval, I'm trying vectors, I'm trying Colbert, I'm trying this other. So they're running around trying these different methods, but they haven't got the kind of basic evaluation methodology or mind of thinking. Yeah.
Yeah. And I think that's like a good prelude, basically, like the user perception and what you're building, and that you're trying to basically map this together. Can you maybe go into like why do we actually want to map data, especially into like dense representation, or in general, like representations that's numeric?
Yeah, there's a great paper from Ginny Lin on conceptual framework for why we want to have a representational approach in information retrieval. So the idea is that in a retrieval system, you have some kind of collection of documents that you want to search through and retrieve information from. And you have a user with an information need, and the user expresses this information need. Then we can have the system essentially interact with each of these documents in the collection. If you have some kind of magic model, let's say, that can estimate if this document is relevant for this query, then we can basically iterate over all the documents in the collection, invoke this model, and the model can say if it's relevant for the query or not. And we can do this for all of the documents. But the problem, of course, is that this is rather compute intensive if you want to build a system that is responsive and that maybe also have a low cost. For instance, at Google scale, they cannot spend a lot of compute per query because they have a lot of documents. And this is where you turn to a representational approach so that you can map the query text and the document into some kind of representation, matching with a similarity metric that you can perform a search in a sublinear time, meaning that you don't have to consider every single document in the collection to invoke this kind of magical model. So that's the whole premise of the representational approach. So there's a lot of words to describe like what most people would think like an Elasticsearch. Oh, I need search. I'm gonna go with Elasticsearch. Gonna index my documents. They will tokenize it, invert it, and so forth. But that's one type of representation. Then you have a vector database. Oh, they're dealing with a dense vector representation. They're dealing with vectors. So I input my vector. But they are all representational approach. And the idea is that you can do this to scale the system so that make it cheaper. And he also touches on in the paper supervised representations versus unsupervised representations. And basically if the representation is learned or not. And if you look at the text embedding models that people are maybe familiar with, OpenAI, Ada, and so forth, they've been taking text and documents and inputting it through a transformer-based model or some kind of model, and then they learn these representation from relevance data, where you have like this for this particular query, this document is relevant. For this particular document, this document is, but it's irrelevant. And using that training data, you learn representations and you learn how to map these queries and documents into this vector space so that the relevant documents are closer in this space and the irrelevant documents are farther away. You can do this also with sparse representations, like we've seen a model called Splade, which also uses a transformer model, learns representation, but instead of having a dense representation where all the dimensions have a value, they essentially cut out a lot of the dimensions and they have a sparse representation. And yeah, there are a lot of variants around this, but if you compare it with BM25, for example, which is also a text scoring or representation, you don't have a learned representation because it's In one way, it has a learned representation because it has seen all the documents, it knows all the birds in the collection, it knows the kind of frequency. So it's more like a statistical analysis of your corpus. And but we still, since it has very few hyperparameters, we call it like an unsupervised method. So I really recommend reading that paper because I think it's a very good overview, and also setting like vector databases versus search engines versus whatever in context.
Yeah, and especially the separation between the physical retrieval model and like the logical scoring model, which basically gives you like these like the this nice 2x2 on dense or sparse and supervised and unsupervised. Do
Yeah.
you think the dense unsupervised area is a little bit underexplored at the moment?
Dense unsupervised, in one way, a lot of so they've been trained on some generic data like MS Marco, which is this huge relevancy data set from Bing. So there aren't that many available data sets to train these type of models. Most of the ones that you find on Hugging Face have been trained on this data set. And you can generate data synthetically, or if you have data internally, like what you're building, you can also train your own text embedding models. But I think most people actually use them off the shelf and then hoping that the learned representation from MS Marco will work for their particular search use case. And even they're getting better and better, these embedding models, they still might struggle what I call in the out of domain setting, meaning that it might not be your use case for search or retrieval might not match with what they were trained on.
Yeah.
And there's a paper or a benchmark called the Beer benchmark. I'm sure you touched on this, which is a collection of different data sets where you can evaluate models that are like generic, unsupervised models and apply them to beer and then see how they perform. And in the first rounds, I think the models that will represent text as a single vector, as a regular text embedding model, they were actually underperforming like the traditional baseline of BM25. In a lot of my work around search and retrieval, when I'm writing about this, I try to include the baseline. And BM25 is actually a pretty good baseline to what's the minimum you can do when you're building a search product. I would say, okay, let's start with the baseline, and the baseline is BM25.